Alrighty, good morning everybody and welcome to the wolfSSL live webinar, uh, migrating from OpenSSL to wolfSSL with our engineer Jacob Bartholomew. My name is Kajal Subkota and I will be moderating this webinar. All attendees will be in listen-only mode. If you have any questions, please feel free to use the Q&A box or raise your hand to be unmuted and you can ask the question live, as we will host a Q&A session following the presentation. The webinar will also be recorded and made available on our YouTube channel shortly after the presentation. I invite everybody to follow us on Twitter at wolfSSL, as well as all of our other socials. And feel free to email us at facts@wolfSSL.com if you have any additional questions. And now I'd like to give a brief company overview. wolfSSL was founded in 2004 by Todd Auska and Larry Stefanik when they realized there wasn't an open-sourced, dual-licensed embedded SSL library available. OpenSSL existed at the time, but there was a demand for an alternative that was easily portable, smaller, faster, available under a clear commercial license, was equipped with a clean and modern API, and offered commercial-style developer support. wolfSSL was born into this market need with an OpenSSL compatibility layer. Today, wolfSSL secures over 2 billion connections. We have more than 1,000 OEM customers and dozens of resellers. wolfSSL is made up of almost 40 dedicated employees in 2020, most of which are engineers. This process, of course, is supported by a strong partner network that we're proud of, which includes Microsoft, STMicro, and Curl, for example. Since the beginning, our engineering team has developed several embedded security products, including WolfCrypt with the DO178 support, FIPS certification, and a FIPS-ready offering, MQTT up to the version 5 specification, SSH v2, TPM 2.0, a secure bootloader known as wolfboot, as well as Java wrappers and JSSE support, and commercial support for curl. All of these offerings are accompanied by a thorough maintenance program and support plans up to the 24/7 level. We also offer full service consulting. And now I'm going to hand it over to Jacob.
Thank you, Kajal. Yeah, as mentioned today, I'll be covering a bit about the wolfSSL compatibility layer, going over the four main topics of what is the wolfSSL compatibility layer, building wolfSSL with the compatibility layer, a simple example application demonstrating its use, and examples of major projects that the feature has been used in. So Kajal already mentioned a lot about what wolfSSL is, us being dual license. A couple of things though that I'd like to bring up that are relevant to the compatibility layer is our FIPS certification, our DO178 certification, some of the progressive cryptography leading the TLS 1.3 adoption. And one of the other things to bring up regarding the compatibility layer is our resource conscientious design that we do that is developed for use in embedded IoT devices, but scales really well when used on places such as large server farms or desktops. There are many features that wolfSSL provides. One of those features is the OpenSSL compatibility layer. This provides a means for making calls to wolfSSL native implementations of functions that behave similar to OpenSSL API functions. With the use of macros, it maps a subset of OpenSSL APIs down to wolfSSL native APIs. And the compatibility layer is constantly getting expanded. as new projects get completed, and there are currently more than 800 of the most commonly used OpenSSL APIs supported. In addition to mapping functions, there's also support for a subset of structures and common enums. Our last release that we did, wolfSSL 4.6.0, it included quite a few ports and, as I mentioned earlier, expansion to the OpenSSL compatibility layer. So it's actively being worked on and expanded to make it easier as we go for new projects to switch from OpenSSL over to wolfSSL. An example of a few of the crypto API supported would be implementations for things such as like the EVP and bio functions. Covering a bit more about the crypto API supported, there is support for EVP init, update, and final function calls. In addition to the init, update, and final functions, there is signing and verifying with EVP API available. These EVP functions mentioned are abstracted functions that OpenSSL uses for many different underlying algorithms, such as performing an RSA operation, signature operation, or doing AES encryption. There is additional support for direct calls to hashing algorithms like the function SHA and SHA-256, along with support for direct calls to AES encryption and decryption. The P-key structures are supported to help with using the crypto, and we have X509 API mapped to by the compatibility layer. This allows for loading in and working with keys using an unaltered application that was previously linked to OpenSSL. The problem that the compatibility layer solves is with having all of these APIs and structures mapped, it allows for easily migrating from OpenSSL to wolfSSL. This is with having an unaltered application that was previously linked to OpenSSL and migrating it over to wolfSSL by only updating the link and include paths. Here's a brief snapshot of the main header for the wolfSSL compatibility layer. This is located in wolfSSL, OpenSSL, SSL.h. All of our OpenSSL headers for mapping the macros are going to be located in that directory. It shows places where the names of OpenSSL structures get mapped to wolfSSL implementations. It also shows a couple of the main TLS API mappings. The bulk of the code mapping APIs will be located in this SSL.h file. But we have at least stubs for all of the other header files so that you don't have to change your include paths. Before getting into the example application and how to build wolfSSL for use with the compatibility layer, I'd like to cover why someone would want to turn on the compatibility layer feature and why they may want to migrate from OpenSSL to wolfSSL. There are many reasons for wanting to make this migration. I listed out some of them on this slide. One reason is that there is a lot of hardware acceleration ports that wolfSSL offers, from the usual ARM assembly or Intel AES-NI, all the way down to embedded uses, like with the Freescale MMCAU. Another point of interest to many is the addition of progressive algorithms and the early adoption of TLS 1.3. Also, with the reduced footprint size of wolfSSL, their users are able to reduce the number of resources dedicated to TLS connections. Later on, with an example in this presentation, I will show just how much the heap size can be reduced simply by migrating from OpenSSL over to wolfSSL. And lastly, we have a clear license model with our code. Sometimes that can get a bit murky when trying to use OpenSSL, especially in things like commercial products. A couple other reasons for the migration, maybe for the FIPS code offered, to get support from engineers who work with and wrote the code. We have a seller support team, and you get connected with engineers who actually did the work and wrote the code. Going over a bit of the FIPS support and why you'd want to do the migration in regards to FIPS support. A lapse in coverage for OpenSSL FIPS projects is happening. OpenSSL FIPS modules dropped to the historical list in September 2020 and will not have a new module available until it's projected until 2022. With the wolfSSL compatibility layer, it is easy to plug wolfSSL into a project that will be affected by this lapse of OpenSSL FIPS coverage, keeping the project up to standards and possible requirements. The FIPS certified code with wolfSSL is used in many existing projects, and a full list of our supported OEMs can be found on the NIST site or up on the wolfSSL website. There are multiple Linux projects listed there that have been done. The list even includes OSs such as Android and FreeRTOS. In addition to maintaining FIPS support, wolfSSL has a FIPS ready build that helps with getting projects ready for FIPS validation. This FIPS ready build lets users run a code base very similar, if not the same, as what would be put through the labs for certification. That covers the basics for what the wolfSSL compatibility layer is and its value when used with a project. Next is going through the steps of turning on the feature when building the library. To build with the compatibility layer enabled, when using auto tools, the flag enable OpenSSL extra can be used. In addition to the OpenSSL extra flag, there is also an OpenSSL all. OpenSSL all enables a superset of implemented functions by including some of the API implemented when expanding for use with new open source projects. If building in an IDE or cases where AutoTools is not being used, then the macro OpenSSL_extra can be defined. This macro can either be passed as a preprocessor flag, or better yet, set in a user_settings.h file. When linking against the wolfSSL library and having built using AutoTools, the file wolfSSL options.h should be included first before any other headers that are used from wolfSSL. The inclusion of options.h first is to make sure that the application is using the same settings as what the wolfSSL library was built with. All header files needed for migrating an application over to wolfSSL are located in the directory wolfSSL OpenSSL, as mentioned before. An example of that is the ssl.h header file listed at the bottom of this slide. With the internal behavior of wolfSSL being different than OpenSSL, there is some cases where only stub functions were needed in projects. These are functions that allow for compiling the code, but do not actually do anything when called. It is also the case that when migrating some projects over to wolfSSL, the features were not needed, so the functions were not finished at that time. It can be useful to tell whether your application is calling a stub function or not. And to help with that, either the debug feature can be turned on with enable-debug, or the macro no_wolfSSL_stub can be defined. Turning on the debugging prints out a warning message each time a stub function is called, and defining the no_wolfSSL_stub macro will throw a compile time error if the application is attempting to use any of these stub functions. Additional features such as like the key generation and algorithms need to be controlled with the enable options such as enable key gen. OpenSSL Extra does turn on a lot of the features that you would typically see with a default build with OpenSSL, but you still need to, if you're looking to do key generation, sometimes with certificate requests, cert recs, you would also need to do the enable dash cert rec when compiling wolfSSL. That covers the basics for how to build the wolfSSL library in preparation for the Great Migration. The next items are covering how to use the library once built and example cases of projects that the feature has been used with. When migrating an application from OpenSSL to wolfSSL, one of the things that needs to be resolved is including the right header files. OpenSSL headers should no longer be used, and the headers files located in wolfSSL should be used instead. This is typically achieved in one of two ways, either with changing the include path to point to the wolfSSL directory with the OpenSSL compatibility header files, or by changing the application code to have wolfSSL prepended to the includes. In most projects, we opt for the first option because it does not require any code changes in the application and is done by simply adding to the include path when compiling. The next thing that needs to be updated when migrating a project over is the library that it is linking to. When an application is linking against OpenSSL, it uses the flags -lSSL and -l crypto. This should be changed to be -l wolfSSL so that the application is now linking with the wolfSSL library instead of OpenSSL. After doing those two things, the migration is complete, and updating the library from the application from using OpenSSL to wolfSSL is complete at that time. Okay, here are two examples of altering the include path and library linked to. The source file, the Great Migration, is a simple TLS server written for the demonstration that uses OpenSSL APIs. The first example command line executed has the application using OpenSSL headers and linking to the OpenSSL library. The second command line executed shows updating the include path to point to the directory where wolfSSL headers are. In addition to adding the include path, I also use the --include flag, which tells the compiler to include wolfSSL options.h as the first include file when compiling any source code. This is to make sure that the application is getting compiled with the same wolfSSL settings as what the wolfSSL library was compiled with. And finally, to have the application link to the wolfSSL library created, links to -SSL and -L crypto were changed to -L wolfSSL. For executing each of these commands, a.out executable was produced when linking to the OpenSSL library, and wolf.out executable was produced when linking to wolfSSL. This slide shows a small code snippet of the example TLS server used. It shows the bulk of the TLS code after a certificate has already been loaded and a client has initiated the TCP connection. In the code, only OpenSSL API was used, which when using the wolfSSL compatibility layer gets mapped down to wolfSSL native API. So you can see it looks like your standard OpenSSL application. And this shows how easy it is to just swap out the include pass and which library it's linking to. Okay, this slide highlights the difference in heap used with default builds from each of the libraries. To collect the heap usage, I built the application on Ubuntu 18.04 and used Valgrind's massif tool. Then to make the pretty graphs for displaying the results, massif dash visualization was used. In both cases, the cipher suite used for the TLS connection was ECDHE, RSA, AES, 256 GCM with SHA-384. And the same client was used to connect to both of the servers once they were running. With using the default OpenSSL version 1.1.1 on Ubuntu, the peak heap used during the connection was 202.6 kilobytes. In contrast, when linked against wolfSSL version 4.6.0, configured with the OpenSSL compatibility layer, the peak heap used was 36.5 kilobytes. Each of these examples was with the default builds. wolfSSL also has some optimizations that can be set for reducing the amount of resources even more. This graph shows one such optimization with using the small version of the SP math library. That was a recent feature that was added into wolfSSL. We previously had the SP operations for speeding up public key sign and verify. But we also added in what we call the SP math all, which is more of just like a SP math library covering more generic stuff than the focused optimizations that we had before, which is the sign and verify. So using this more optimized build, we can see it takes only a peak heap usage of 27.7 kilobytes. And this is using the same code without changes, just linking to wolfSSL that's been built with the more optimized math library. That covers an example of using the compatibility layer and the resource use reductions. The final item to cover is examples of major projects used in and determining if all APIs needed for migration of your project are available. This is a list of some of the major projects that the compatibility layer has been used in. For many of the major open source projects that we port to with the compatibility layer, there's an associated enable option. This is to guarantee that all features used by the open source project, like I'd mentioned before with the enable keygen, are enabled when wolfSSL is compiled. An example of this would be to use the enable-nginx for enabling the HA proxy flag, or enabling the HA proxy flag, excuse me. The full changes done for nginx and Apache can be found on the wolfSSL GitHub page. So this slide shows the enable nginx or also the enable HA proxy. With the compatibility layer being a subset of all possible OpenSSL API, there is a chance that some API used in your application may not yet be implemented. One of the easiest ways to tell if there are some missing gaps in the implemented API is to compile the application and attempt to link it against wolfSSL. We'd also recommend using the no_wolfSSL_stub when trying this. That will list out at compile time any errors for all unimplemented functions. If it is found that some of the API were missing, we do accept feature requests, or we offer consulting for expanding the compatibility layer as needed for specific projects that come up. One of the things that we found and have added recently is if too many API are missing, wolfcrypt can be used as an engine with OpenSSL. So this one, when using it that way, it wouldn't be like a complete replacement of OpenSSL. It would just be plugging it in as a new engine. And for some of the FIPS projects, we're finding that can be a valid route as well. Yes, that gives a summary of what the wolfSSL compatibility layer is, why it would be used, and example cases. At this time, I guess we're going to open up the floor to any questions.
Awesome. We have a question here that is asking, what are the top reasons that people migrate from OpenSSL to wolfSSL?
Sure. Top reasons, at least lately, has been the FIPS lapse in coverage that OpenSSL is experiencing. So we've seen quite a few people come to us with FIPS requirements that we've handled for them. And outside of the FIPS requirements, a lot of people like the support that we offer. We offer very quick support. Our engineers who, like as I mentioned, actually who wrote the code and are knowledgeable about it respond quickly to any questions that you might have regarding it. And then one of the other big things is the resource reduction. We've had cases where people simply ripped and replaced OpenSSL on a big server farm, and for example, they're able to handle thousands more TLS connections in the same resource with the same resources that they had previously been tied up with using OpenSSL.
Fantastic. Did you say you could use the wolfcrypt as an engine with FIPS?
Yes, that's correct. That's something that's relatively new. So you can contact us at facts@wolfssl.com and we can get you information regarding that. But that is one route that we're doing with some of these FIPS projects that have just too many OpenSSL APIs missing.
Do you have a plan to support OpenSSL version 1.1, which the latest QT requires?
I don't know, so we have specific OpenSSL versions on our roadmap. We do have a port to the QT project, and that's something that I guess you could contact us at facts@wolfSSL and we could see about if we need to update our port. But yeah, I can't say as we have the specific version of OpenSSL. We try to make the compatibility layer in such a way that it works for as many versions as possible. Yeah, I think you'd have to contact us for like the QT port and see if we need to make an adjustment there. I wasn't aware that we needed to.
Can you go into more detail about using wolfSSL as an engine? For example, I have a user application that uses the OpenSSL engine interface in order to access an HSM or TPM, and I'd like to use wolfSSL, wolfcrypt, wolfTPM to access a TPM.
Sure. So with the TPM, that makes it a little bit more complicated. We do have the PKCS11, we have the Wolf TPM. As far as more information about the wolfcrypt engine, I know of the project, but I haven't touched as much of the code with that project. So it's something that I would certainly recommend that we follow up on and then get you more information.
And is the Wolf engine going to be offered as a separate project, or will it become a part of wolfSSL/wolfcrypt?
Sure. Yeah, I don't know if that's been determined yet. But like I mentioned, that's a relatively new thing that we're adding in.
Okay, awesome. For embedded applications, how does the code size compare with OpenSSL?
Okay, with embedded applications, wolfSSL is very modular. So we have builds where the code size is significantly smaller. And then we have performant builds where the code size, I think, would be relatively close to OpenSSL. So it depends on how you build wolfSSL. But we can get a much smaller footprint size at the expense of doing a little bit less performance.
If we're using libcurl with OpenSSL, will the compatibility layer allow us to use the OpenSSL path of libcurl, or do we need to move our extra loggings into libcurl's wolf mode?
Okay, if this is like an earlier version of libcurl, that might be an option. But I know the most recent libcurls, they have an enable option to just build with wolfSSL. Daniel, the maintainer with libcurl, he works with wolfSSL, and we have good supported build options with at least with the most recent versions of libcurl.
Why is the wolfSSL/options.h not included by the wolfSSL/OpenSSL/SSL.h and other files when migrating third-party products like libSSH2? One has to modify either the source or the build procedure of libSSH2 to make it work. And when that is omitted, the resulting code crashes.
Okay, we've recently done some updates to like our settings.h file to try and include the wolfSSL options.h. So I'd have to double check on that. It might be that the most recent versions of wolfSSL we can get around it, but if not being able to build with a or if not being able to use include the wolfSSL options.h, you can go the route of using user_settings.h and just having all of the same defines as what would have been in options.h placed in user_settings.h, and then use the macro wolfSSL_user_settings when building, and that'll automatically try and include the user_settings.h. We often do that type of build for like embedded devices and IDEs, but it could be a good solution in this scenario as well.
Are there plans to provide an equivalent of the OpenSSL binary? I guess they need that to generate certificates, tests, etc. So they still need to build and maintain OpenSSL and wolfSSL both.
Yeah. So the command line utility. Yeah, we have the start of a command line utility. We call it wolfclue in our examples repository. It has some of the basic stuff, such as like I believe there's certificate generation in there and some of the algorithms for some operations with some of the algorithms. It's something that we would definitely like to see. It's just I don't know as though it's on our roadmap for this year or not. But yeah, I would take a look at our examples repository, and it's the name wolfclue, wolf CLU. And it's at least the start to the binary. And then you could contact us with feature requests, and we can see about expanding it more.
Can you use the compatibility layer with FIPS Ready?
Yes.
Is it possible to use Wolf Crypt on top of OpenSSL?
Crypt on top of OpenSSL. Is this in regards to like the engine? I'm not sure.
I'm not sure either. If you could maybe elaborate on your question a little bit, we'd be able to answer that.
Yeah, if this is in regards to like coexisting with OpenSSL, we have a coexist flag. It's sometimes you run into issues with specific builds with wolfSSL, so we recommend replacing when possible.
Okay, and then is the OpenSSL 3.0 compatible with wolfSSL?
That's a good question. The upcoming module that OpenSSL is doing. We haven't done much with the compatibility layer yet with the most recent OpenSSL module. If I remember right, I think they're changing some of the API and doing a lot of refactoring, which we haven't adjusted for with the compatibility layer.
Okay, and does wolfSSL support PKCS 11 standard?
Yes, yeah, we support PKCS 11.
Awesome. I think that, oh, one more. Do you releases of Wolf with other operating systems like AIX, Solaris, HP, UX, and their native compilers?
So the bundle that we release is purely source code. We don't have any pre-built binaries, but we have tested building the source code with OSs such as Solaris.
Fantastic. And I think that was the last of our questions. Thank you everyone for attending our wolfSSL live webinar, migrating from OpenSSL to wolfSSL. I just want to remind everybody that this webinar is recorded and will be made available via our YouTube channel. And if you would like to receive slides for this webinar, we do that too. However, the slides are by request only. So you can just send an email to facts@wolfSSL.com requesting for the slides, and we'll send that right over. Thank you, Jacob, for a fantastic presentation. And as a reminder, please follow us on all of our socials at wolfSSL. And feel free to also email us at facts@wolfSSL if you have any additional questions or need any more help. Thank you so much.
All right, thanks, Coach.
Mm-hmm.